It's time to get your arrows popping. Ladies and gentlemen, this is Mr. Whitt with Fort Bend Tutoring. In today's tutorial, we'll be talking about solving a system of linear equations using the Gaussian method. That's right, the Gaussian Elimination Method. And if you think that I'm mispronouncing the name Gaussian, you're probably right. Yes. So I'm going to be butchering this name the entire video. So just stick along as we focus on how to solve a system of linear equations using row echelon form. That I think I can say. But first, let's go ahead and have you click on the subscribe button, and please feel free to click on that bell notification so that you can be notified when we're uploading new and fresh content for you. That's right. Go ahead and click right now on the subscribe button. That's right. I'm waiting for you. Okay, good. I appreciate that. Let's continue. We have the Gaussian method. That's right. So the steps that we'll follow in this video are to one, write an augmented matrix. Then we'll be simplifying that matrix into a row equivalent matrix in row echelon form. And then finally, we'll use back substitution and solve the system of linear equations. That's what's going on in this here video, guys. I'm really excited to share this method with you today, and make sure that you stick around to the end where I'll be sharing an example of how to solve a word problem using this process right here. So let's go ahead and look at problem number one, where we're given a system of linear equations. We have two variables with two equations. I have the first equation here, which is x plus 2y equals 8. I have the second equation, which is 3x minus 4y equals to 4. And what is the first step, guys? That's right. We want to write our system in an augmented matrix, and it's going to look just like this. Let's go ahead and take a look at it. We'll be needing the coefficients from both equations. I'll start out with 1 coming from that 1x. I'll need a 2 from the 2y, and then I'm going to have here that solid line separating the left side of the equations from the right side of the equation. And then I'll bring down that 8, and I'll also have the second row, which has coefficients 3, -4, and then we have that set equal to 4. And this is my augmented matrix, guys. Here we want to rewrite the augmented matrix in row echelon form. So our goal here is to make sure that we have ones down this main diagonal here. That diagonal comes from the upper left down to the lower right, with zeros underneath or above, for that matter, the main diagonal. Okay, so we want a triangular form. That's right. And the triangular form simply means that along this main diagonal here, that there's going to be zeros found above it or beneath it. But in most examples that you'll see that they'll have zeros beneath the main diagonal here. That is your goal here for getting your matrix simplified in row echelon form. So in order to get a 0 here where the 3 is, I'm going to show that my row operation is going to be to multiply -3 times row 1, add that to row 2, and then put the result in row 2. That means that the first row will remain the same. I'll have a 1, a 2, then an 8 in that first row. Whereas in the second row, after multiplying 1 times -3, you'll get -3. -3 plus 3 gives me 0 for that first element in the second row. Then I'll be multiplying 2 times -3 to get me -6. And then -6 plus -4 gives me -10. All right. And that becomes the second element in the second row. From here, we'll go ahead and multiply -3 times 8 to get -24. Then adding -24 plus 4 gives you -20. All right. So remember, our main diagonal, this diagonal that contains the 1 and the -10, is where we want every element to be a 1 to get it in row echelon form. Currently, what you're looking at is triangular form, and technically you could stop right here and rewrite your system using the information that you have here and go ahead and solve your equation. However, to put it in row echelon form, you'll want that second element in the second column, this -10 here, you'll want it to be a 1. So let's do just that. In order to make this -10 a 1, my next row operation is to have row 2 divided by -10, and then put that result in row 2. So this is what we'll be doing here for our last step to get it in row echelon form. Go ahead and bring down that first row as 1, 2, and 8. And then for the second row, remember, we're dividing everything by negative 10. So 0 divided by negative 10 is 0, and negative 10 divided by negative 10 is 1, and negative 20 divided by negative 10 is positive 2. You now have the problem in row echelon form, guys. So this is what we're looking for when doing your row echelon form using the Gaussian elimination method. Let's move on to the next page. So remember, it's once you have it in row echelon form that we'll go ahead and back substitute and rewrite our system of equations using the information here. So back substituting, recall that our first column is for the x variable, where the second column is for the y variable. Knowing that, I can rewrite our equations as x plus 2y equals 8, and the second equation will be y equals 2. Since we know that the variable y equals 2, we can use substitution in the first equation to rewrite our equation as x plus 2 times 2 equals to 8. And from here, we'll go ahead and simplify and solve for x. So this gives us x plus 4 equals 8, and then solving for x, you'll be subtracting 4 to both sides, and you'll end up with x being equal to positive 4. Now that we have our answer for both x and y, your solution set will be 4 and 2. Red, box it. That's right, people. So you can write your answer as an ordered pair, or you can expand this, knowing that the first value in the ordered pair is x, knowing that the second value in the ordered pair is y, and simply have x equals to 4 and y equals to 2. Done and done, people. Just like that. All right. So most of your instructors will want the answer to be as an ordered pair in this case. If you have more than 2 variables, let's say you have 3 variables involved in your system of equations, you'll write your answer as an ordered triple. So that concludes problem number 1. Let's check out problem number 2. And in problem number 2, notice that we have 3 equations with 3 variables. So in this case, we'll end up with an additional row and column when we're setting up our augmented matrix. All right, so let's see what that looks like. We're going to set up our augmented matrix using the coefficients once again from the system of equations. You'll have 1, 2, 1, and then 7 for this answer column here. With the second row, you'll have coefficients 1, 2, 3, and then 11. In the third row, you'll have 2, 1, 4, and 12. So recall that our goal is to put this in row echelon form. We want the main diagonal right here that currently has 1, 2, and 4. We want those values in that main diagonal to be 1s. We want the values underneath the main diagonal to be 0s in order to put it in row echelon form. So what I prefer to do, guys, is focus on one column at a time. So I'll be focusing on this first column, making sure that that first element in the first row is 1, and it is, and then making zeros underneath that 1. So that means that this second row's first element of 1 here has got to go. I need it to be a 0. So I'm going to have as my row operation row 1 minus row 2 and putting the result in row 2. Okay, just like this. So that being the case, I know that the first row and the third row are going to be unchanged. So I'll be bringing down this 1, 2, 1, and 7 in the first row. And in the third row, I'll be bringing down the 2, 1, 4, and 12 in the third row. What I will be changing is the second row, knowing that I'll be subtracting these 2 rows here, or you can say that I'll be adding the opposite of row 2 to row 1. So carrying this operation out, I'll have 1 minus 1 is 0. I'll have 2 minus 2 is 0. I'll have 1 minus 3 is negative 2. And I'll have 7 minus 11 is negative 4. All right, so this is what we have so far. In our next step, I'm going to show that I'll be swapping out row 2 with row 3. The reason why I want to do this, guys, is because I want to keep in mind that I want this main diagonal here to have coefficients of 1. down the main diagonal. And it's going to be a lot easier for me to make that happen if I swap out the second and third row. So we're going to be bringing down the first row as it is, this 1, 2, 1, and 7. And then by swapping out the second and the third rows, I'm going to end up with 2, 1, 4, 12, while the third row will now be 0, 0, -2, -4. So the next thing I'll be doing is I'll be creating a 0 right here for that first element in the second row. And the way I'm going to do that is I'm going to use the following row operation. I'm going to have -2 times row 1 plus row 2 and then put that result in row 2. So that means that we now have row 1 remaining the same again, 1, 2, 1, and 7 here, guys. And then the third row will stay the same, 0, 0, -2, -4. And then I'm going to have -2 times 1 gives me -2, -2 plus 2 gives me 0. Then multiplying -2 times 2 gives me -4. -4 plus 1 gives me -3. And then -2 times 1 gives me -2. -2 plus 4 is +2. And then I'll have -2 times 7, which is -14. -14 plus 12 is -2. And we have our resultant row after our row operation here. Staying consistent, our next step is to make this -3 a 1. So what I'll do then is I'm going to take row 2 and divide it by -3, putting the result in row 2. So what this will look like is the first row remaining the same, 1, 2, 1, and 7. And I'm going to go ahead and write out my third row, knowing that it won't be changed in this step here. Then focusing on the second row, 0 divided by -3 is still 0. -3 divided by -3 is 1. 2 divided by -3 is -2/3. And -2 divided by -3 is +2/3. So this is what I end up with here after dividing each and every element in row 2 by -3. Remember, the purpose in doing so was to make sure that I ended up with a +1 on my main diagonal here. The last step that I'll need to do in order to put this matrix into row echelon form is to make the third row, third column's element a +1. We can do that by dividing by -2. So I'll have row 3 divided by -2, placing the result in row 3. So this is going to be my last step in order to put the matrix into row echelon form. So I'm going to bring down row 1 as 1, 2, 1, and 7. Then I'll have 0, 1, -2/3, as well as +2/3. I hate the 2 there. Let's fix the 2. This is a better 2. There we go. Then in the third row, we'll be dividing each and every element by -2. So 0 divided by -2 is 0. 0 divided by -2 is 0 once again. And then -2 divided by -2 is +1. And -4 divided by -2 gives you 2. There you have it. So now we have row echelon form, guys, with 1s in the main diagonal, 0s underneath the main diagonal, and the next step is to back substitute. Continuing the process, we're going to be now back substituting into a system of equations. So I can rewrite this as x plus 2y plus z equals 7. Then in the second equation, because this first term is 0, that means your coefficient on x is 0, and you don't have to write 0x. You can simply write this as 1y minus 2/3 z equals 2/3. And then for your last equation, you'll have z equals to 2. And this will be your simplified system written from your row echelon form. So since I know that z equals to 2 now, I can go ahead and plug that in to the second equation. So I'll have y minus 2/3 times 2 equals to 2/3. From here we'll have y minus 4/3 equals 2/3. So I'm going to be adding 4/3 to both sides. And that gives me y equals 6/3. When I simplify 6/3, I'll get 2. So for now, I know that z equals to 2 and y equals to 2 as well. So finally, we'll be plugging in z equals to 2 and y equals to 2 into this first equation from our system. So now that we know what y and z is, we'll be plugging it in to get x plus 2 times 2 plus 2 equals 7. Multiplying 2 times 2 gives you 4, right? And we'll have x plus 4 plus 2 equals 7. Combining our terms on the left side of the equation, we'll have 4 plus 2 gives us 6. And then finally subtracting 6 to both sides of the equation, we'll find that x equals to 1. Therefore, our solution written as an ordered triple is going to be 1, 2, 2. And this is our answer. Red, box it. That's right, guys. So now that we know that our value of x equals to 1, our value of y is 2, and our value of z is 2, this is the ordered triple, which is your answer. Once again, you could expand this by saying x equals to 1, y equals to 2, and z equals to 2. But this is a preferred and standard way of writing your solution as well. All right, that was problem number 2. All right, so I want to remind you guys that you could set up a paid online tutorial today with me, Mr. Whitt, and Fort Bend Tutoring by going to our website, fortbendtutoring.com. There you'll find links and resources to different math material, as well as links to our merchandise. All right, so let's go ahead and get back to business with problem number 3. All right, with problem number 3, we have another system with 3 equations and 3 variables. We know that our first step is to rewrite this as an augmented matrix. So that's exactly what we're going to do. All right, so that means that I have coefficients 1, 3, 7, as well as 1 on the right side of our augmented matrix. We have in the second row 3, -1, -5, and 9, and then finally we'll have 2, 1, 1, and 4. So we'll be keeping in mind that we want this main diagonal to be filled with 1s with 0s underneath the 1s, okay? So that means in my first step here, after writing the augmented matrix, I'm going to focus on getting 0s in that first column underneath that first 1 in the upper left-hand corner there. So I'm going to do the following row operation. I'm going to have -3 times row 1 plus row 2 and putting the result in row 2. From here, I know that my first and third rows are going to go unchanged. So I'll just bring those down. We'll have 1, 3, 7, and 1 in the first row. And in the third row, we'll have 2, 1, 1, and 4. Then following our row operation, I'll have -3 times 1 gives me -3, and then -3 plus 3 gives me 0 here. Moving on to the next element, we'll have -3 times 3 gives me -9. -9 and -1 give me -10. Then I'll have -3 times 7 gives me -21. -21 and -5 give me -26. And then -3 times 1 is -3. -3 plus 9 gives me +6. And this is what I have now for my new row 2. Our next step is to create a 0 for the third row first element. That means I'll be doing the following row operation. I'm going to have -2 row 1 plus row 3, putting the result in row 3. So it'll look like this. This first row will remain the same. We'll have 1, 3, 7, and 1 here. The second row remains the same. We have 0, -10, -26, and 6. However, the third row will first multiply -2 times 1 to get -2. -2 plus 2 gives us 0. Then multiplying -2 times 3, you'll have -6. -6 plus 1 gives you -5. And then -2 times 7 gives you -14. -14 plus 1 gives you -13. And then -2 times 1 is -2. -2 plus 4 gives me 2. So this is going to be our new third row for our row equivalent matrix. The next thing I want to do is I want to create a 0 where this -5 is. So I'm going to be doing the following. I'm going to have -2 row 3 plus row 2, placing the result in row 3. What does that mean for me? That means that my first and second rows will remain the same. I'll have 1, 3, 7, and 1 for that first row. Then for the second row, we'll have 0, -10, negative 26, and 6. And then finally, to get our third row, we're going to be multiplying row 3 times negative 2 and then adding it to row 2. So we'll have negative 2 times 0 plus 0 gives you 0. Then negative 2 times negative 5 is 10. 10 and negative 10 combined to give you 0. Multiplying negative 2 times negative 13, you'll have 26. 26 and negative 26 gives you 0. Then multiplying negative 2 times 2 gives you negative 4. Negative 4 plus 6 gives you positive 2. It's at this point we're going to stop. The reason why we're stopping is because anytime your Gaussian elimination yields an equation in the form of 0, 0, 0 with a non-zero number, well, in that case, you're going to end up with an inconsistent system, which means there's no solution to this system. So due to this equation right here, due to this 0x plus 0y plus 0z equals to 2, the answer is no solution. Just like this, guys, or you can say it's the empty set. Okay, red box it, people. There you go. So this system has no solution. Done and done. And once again, it's called an inconsistent system of equations that has no solution. Moving on to problem number 4. In problem 4, we once again have a 3-equation, 3-variable system. So let's begin with our augmented matrix. So what we'll end up with is 0, 2, negative 1, and negative 5. Notice that we did not have an x term in that first equation. That's why I put 0 as its coefficient. Then in the second row, I'll have 1, negative 2, 2, and 9. The third row will have 2, negative 3, 3, and 14. And with this setup, guys, we're going to go ahead and solve this system knowing that we want our main diagonal to have 1s with 0s underneath that main diagonal. So I'll begin with the following row operation. I'm going to start with swapping out row 1 with row 2. That's going to be my first move. That means that row 3 will remain the same. You'll have 2, negative 3, 3 with 14 on the right side of our augmented matrix here. Then our new first row will be 1, negative 2, 2, and 9, where our new second row will be 0, 2, negative 1, and negative 5. And this is going to be our row equivalent matrix that we have thus far. With our next step, I'll want this 2 to become a 0. So my row operation is going to be negative 2 row 1 plus row 3, putting the result in row 3. So from here, my first 2 rows will remain the same. So that means that I'll bring down 1, negative 2, 2, and 9, as well as 0, 2, negative 1, negative 5. For this third row, however, we'll multiply negative 2 times row 1, then add that to row 3, and then write the result in row 3. So negative 2 times 1 is negative 2. Negative 2 plus 2 gives me 0. Then multiplying negative 2 times negative 2 to give me positive 4. Positive 4 and negative 3 combined to give me positive 1. Then we'll have negative 2 times 2, that's negative 4. Negative 4 plus 3 gives me negative 1. And then we'll have negative 2 times 9 is negative 18. Negative 18 and 14 combined to give me negative 4. All right. And this is going to be the resultant matrix after that row operation. The next thing I want this term here to be a 1. And it looks like I already have a 1 element right here. So maybe we should swap again, guys. Let's go ahead and swap out row 2 and row 3 together. Okay. So with this swap, I'm going to end up with the first row being the same, just like this. And then my second row now being 0, 1, negative 1, and negative 4, while the third row is 0, 2, negative 1, negative 5. All right. So I don't try to predict too much when I'm doing the Gaussian elimination process, guys. I just take the steps as they come. Okay. So I just saw that this was going to be a better situation for me as far as getting my main diagonal to be 1s. So that's what I wanted. From here, I want to get a 0 right here in the third row, second column, where that 2 is. So the row operation that'll help me do that is going to be for me to have negative 2 row 2 plus row 3, putting the result in row 3. So in doing that, I'll be bringing down the first row, 1, -2, 2, and 9. And then I'll bring down the second row as 0, 1, -1, and -4. And then for that third row, I'm going to be multiplying the second row by -2, adding it to the third row. So I'll have -2 times 0 to give me 0, and 0 plus 0 is 0. -2 times 1 is -2. -2 plus 2 gives me 0. And then -2 times -1 is +2. +2 and -1 combine to give me +1. And then finally, -2 times -4 is +8. 8 and -5 combine to give me +3. And now we have our matrix in row echelon form. Notice how my main diagonal is all ones and I have zeros underneath that main diagonal. That means that it's time to back substitute, guys. So I'll be rewriting my equations as x minus 2y plus 2z equals 9, while the second equation will be y minus z equals -4, and finally the third equation is z equals to 3. And now using this simplified system, we can solve for the system of equations much easier. So we already know that our z value is 3, right? And plugging that into the second equation, you'll have y minus 3 equals -4. So in order to solve for y, all you got to do is just add 3 to both sides of the equation. What does that give you? That gives you -1, people. So now we have z equals to 3. We got y equals to -1. We'll be plugging in these two values into the first equation here. So we'll keep in mind that y equals to -1 and z equals to 3 as we plug in those two values into our first equation in our system. Plugging in our values, we'll have x minus 2 times -1 plus 2 times 3 equals 9. Simplifying, you'll have x plus 2 plus 6 equals to 9. We know that 2 plus 6 is 8, right? So we'll go ahead and rewrite it as x plus 8 equals 9. And then subtracting 8 to both sides, you'll end up with x equals to 1. And now you have all three values that you were looking for your variables. With all the values solved for, we'll have our order triple as 1, -1, and 3. Red box it, people. There you go. And that is your answer for problem number 4. All right, let's check out problem number 5. In problem number 5, we have, once again, 3 equations with 3 variables. So by now, you should start getting familiar with the process. You should know that your first step is to rewrite this system as an augmented matrix. So I prefer to make videos that have multiple problems in them, guys, so you can start working on the mastery of the concept, not only just to understand what to do, but also how to do it in a consistent manner. So our augmented matrix will be 1, -2, 2, -4 for the first row, and we'll have 1, 1, -7, and 8 for the second row, and finally we have -1, -4, 16, and -20. All right, so that completes our augmented matrix. So remember, we want ones down the main diagonal here with zeros underneath. So my first focus is to get the 1 in the second row first column to become a 0. How do I do that? I'm simply going to say row 1 minus row 2, putting the result in row 2. Setting this up, we'll bring down our first row as it is. We have 1, -2, 2, as well as -4. And then you'll bring down the third row as is, -1, -4, 16, -20. And then with our second row, we'll be subtracting row 2 from row 1. So 1 minus 1 gives you 0. -2 minus 1 gives you -3. 2 minus -7 gives you +9, guys. That 2 minus a negative makes it a +7. 2 plus 7 is 9. Then you'll have -4 minus 8 gives you -12. And this will be our new row equivalent matrix, okay, for our augmented matrix here. Continuing our process, we'll next want a 0 for the first element in the third row. I can make that happen by adding the first row and the third row together. putting the result, obviously, in the third row. So that means I'll be bringing down the first two rows as is. I have 1, -2, 2, and -4. And I also have 0, -3, 9, and -12, as well as 1 plus -1 gives me 0. -2 plus -4 gives me -6. 2 plus 16 gives me 18. And then -4 and -20 combine to give me -24. And this is my new third row after that row operation now. Next, we'll want to get a 1 down this main diagonal where the -3 is. We can easily do that by dividing row 2 by -3, putting the result in row 2. So once again, we're going to be dividing row 2 by -3 and then putting that result in row 2. So that means that the first row will remain the same. I have 1, -2, 2, as well as -4 for that first row. The third row is 0, -6, 18, and -24. And then finally, dividing each of the elements in the second row, I'll have 0 divided by -3 is 0. -3 divided by -3 is 1. 9 divided by -3 is -3. And -12 divided by -3 is +4. And this is going to be our row equivalent matrix after that row operation. Our next step is to create a 0 where the -6 is. We can do that by going ahead and multiplying row 2 by 6. So if I say 6 times row 2 and then add that to row 3, putting the result in row 3, we should get the 0 where that -6 element is currently lying. So let's go ahead and check that out. We'll be bringing down the first two rows as is. So I have 1, -2, 2, as well as -4. The second row is 0, 1, -3, and 4. And then finally, to get our third row, we're going to have 6 times 0 is 0. 0 plus 0 gives us 0. Then 6 times 1 is 6, and 6 and -6 combine to give us 0. Well, that's good. That's what we wanted. Multiplying 6 times -3, you get -18. -18 plus 18 is 0. And then multiplying 6 times 4, you get 24. And 24 plus -24 is 0. Ladies and gentlemen, anytime you get a row or an equation where all the coefficients are 0, you will end up with a consistent system that has an infinite number of solutions. All right. So what you want to do now is you want to go ahead and back substitute your equation at this point. And you're going to find that you have x minus 2y plus 2z equals -4, while you also have y minus 3z equals to 4. So what we'll realize is that we still have 3 unknowns, but because we have a lack of a third unique equation to find out all 3 variables, is you'll want to write your result reflecting the fact that one of these values can be any number. So what we're going to do is we're going to end up rewriting each of these equations in terms of z. For instance, to solve for y, all I have to do is add 3z to both sides of the equation. Doing so lets me know that y equals to 3z plus 4. I'm going to hold on to this value and then solve for x. In solving for x, I'll be adding 2y to both sides of the equation, as well as subtracting 2z to both sides of the equation. In doing this, I'll have x equals 2y minus 2z minus 4. However, I'm not done yet because I know what y is. Remember, we said that in the previous step that y was equal to 3z plus 4. So go ahead and plug that in for your y term. Simplifying, and I'm going to get my arrows popping. You'll have 6z plus 8 minus 2z minus 4. This all simplifies to give you 4z plus 4 as your result for x, guys. So remember, not only did we isolate the variable x and write our result initially in terms of y and z, because we had determined that all of our solutions were going to be written in terms of z, we then substituted in the value of y that we yielded in our previous step and plugged in that 3z plus 4 in for the variable y. After we distributed and got our arrows popping, we went ahead and combined our like terms and got x equals to 4z plus 4. With these 3 values found now, we'll have our answer as 4z plus 4, 3z plus 4, z. And what this shows is a relationship between the infinite number of solutions. That as long as your x value is 4 times your z value plus 4, and as long as your y value is 3 times your z value plus 4, you will end up with a solution to the original system of equations. Done and done. Red, box it. And that is our answer here for problem number 5. So in this problem, we had an infinite number of solutions, and that's the way you write it, people. All right, let's move on to our next example. In example 6, we once again have 3 variables in a system of equations here. So we're given 3 equations. That's a good start. And our first step remains to write our augmented matrix first. So here, writing our augmented matrix, you're going to end up with the following. You'll have 3, 0, -1, and 1. With your second row, you're going to have -6, 2, 0, -5. You'll then have 0, -4, 3, and +5. And this is your augmented matrix for problem number 6. With this problem, I'm sniffing a little drama on the way. So what I'm going to do is I'm going to take advantage of the fact that I know that I'm going to want the second row, first column element to be a 0. I'm going to take advantage of the fact that -6 is a multiple of 3. So let's go ahead and take care of that first. I'm going to have 2 times row 1 plus row 2, writing the result in row 2. Let's do that, guys. That means that the first row will remain the same. All right. And then the last row remains the same. So we have 0, -4, 3, and 5. And then finally, in order to get the new second row, I'll be multiplying 2 times 3 to get 6, and 6 and -6 combine to give me 0. Then I'll be multiplying 2 times 0 to give me 0, and 0 plus 2 is 2. I'll also have 2 times -1 is -2. -2 plus 0 is -2. And then I'll have 2 times 1 is 2. And then 2 and -5 give me -3. So this is going to be what I end up with after that first row operation. The next thing I want to do is I want to take advantage of the fact that -4 is a multiple of 2. So just trying to ease this process because, like I said, I was smelling drama on the way. So I'm going to try to take advantage of some of these opportunities as I come across them. So what I'm going to do with my next one is I'm going to say 2 times row 2 plus row 3, putting the result in row 3. All right, guys, this is going to be able to give me a 0 down here. So I'll have 3, 0, -1, and 1, as well as 0, 2, -2, -3, as well as with this third row, you'll be multiplying 2 times 0 plus 0 to give me 0. Then 2 times 2 is 4. 4 and -4 give me 0. Then 2 times -2 is -4. -4 plus 3 gives me -1. And finally, we'll have 2 times -3 is -6. -6 plus 5 gives me -1. And this is what we have thus far, guys. Okay. Now, technically, we have a triangular form here. We could just back substitute at this point and solve the system. However, this is not row echelon form. Row echelon form demands that this main diagonal has 1s as the coefficients there. All right. Currently, it does not. So that means in order to make this the case, we'll need to divide everything in row 1 by 3. You'll need to divide everything in row 2 by 2. You'll need to divide everything in row 3 by -1. And that's what we'll do. So in our next step, I'm going to have row 1 divided by 3, placing the result in row 1. Let's check it out, guys. First, I bring down my other 2 rows as those will be unchanged. All right, and this just calms me in my process, guys. Just bringing down the rows that I don't have to mess with, okay? So now I can put all my focus in the row that does need to change, and we'll be going through each of the elements in row 1, dividing by 3. 3 divided by 3 is 1. 0 divided by 3 is 0. -1 divided by 3 is -1/3. And 1 divided by 3 is 1/3, just like that. For our next step, we're going to be dividing each of the terms in row 2 by 2. So we'll have row 2 divided by 2, placing the result in row 2. That means that row 1 and row 3 will go unchanged for this operation. I'll be bringing down 1, 0, negative 1/3, and 1/3. And then the third row will have 0, 0, negative 1, negative 1. For your second row, go ahead and divide each of the elements in row 2 by 2. 0 divided by 2 is 0. 2 divided by 2 is 1. Negative 2 divided by 2 is negative 1. And negative 3 divided by 2 gives you negative 3/2. So in our next step, in order to put the matrix in row echelon form, we'll need to multiply or divide row 3 by negative 1. So I think I'm going to do something different. I'm going to say negative 1 times row 3, putting the result in row 3. Obviously, the first two rows go unchanged. Let's bring those down. We'll have 1, 0, negative 1/3, and 1/3 here, as well as bringing down 0, 1, negative 1, and negative 3/2. And finally, for our third row, we're going to go ahead and change all the signs. So the opposite of 0 is 0, the opposite of 0 is 0, the opposite of negative 1 is positive 1, and the opposite of negative 1 is positive 1. And now we have row echelon form for our augmented matrix here. So now it's time to back substitute. And in back substituting, you'll end up writing your system as x minus 1/3 z equals to 1/3. You'll also have for the next equation, y minus z equals to negative 3/2. And for the third equation, z equals to 1. So we already have one of the three values solved for, which means we'll be plugging in 1 for z in the previous equation. So I'll have y minus 1 equals to negative 3/2. Adding 1 to both sides of the equation, you'll have y equals to 2/2 minus 3/2, which gives you a result of negative 1/2. So negative 1/2 is our value for y. Plugging both of these values into the first equation, we can solve for x. So we'll have x minus 1/3 times z, which is 1, equals to 1/3. Okay, simplifying, you'll have x minus 1/3 equals to 1/3, and then adding 1/3 to both sides of the equation, we'll find that x equals to 2/3. All right, so using these three values that we found, your ordered triple is going to be 2/3, negative 1/2, and 1. And this is the solution to problem number 6. Red box it. Just like that, people. There you go. That is the answer to problem number 6. I want to thank each and every one of you that went ahead and stuck around to the end. And go ahead and let me know if you stuck around as long in the comments, okay? Because the next thing I got to give you is a word problem that we'll use row reduced form in order to solve, all right? AKA the Gaussian Elimination Method. So here we have it, guys. A special low-calorie diet consists of dishes A, B, and C. Each unit of A has 2 grams of fat, 1 gram of carbohydrate, and 3 grams of protein. Each unit of B has 1 gram of fat, 2 grams of carbohydrate, and 1 gram of protein. Each unit of C has 1 gram of fat, 2 grams of carbohydrate, and 3 grams of protein. The diet must provide exactly 10 grams of fat, 14 grams of carbohydrate, and 18 grams of protein. How much of each dish should be used? So for number 7, in solving our word problem here, guys, we'll need to create an equation that represents the fat involved in the diet, as well as the carbohydrate, in addition to the protein. All right, so the equation that represents the fat in the low-calorie diet is 2a plus b plus c equals 10. This lets us know that you will get 2 grams of fat in dish A, 1 gram of fat in dish B, and 1 gram of fat in dish C, and the total grams of fat that the diet will allow is 10 grams of fat. When it comes to the carbohydrate, you'll have A plus 2B plus 2C equals to 14. This is the representation of 1 gram of carbohydrate being in dish A, 2 grams of carbohydrate being in dish B, 2 grams of carbohydrate being in dish C, and that the diet allows for 14 grams of carbohydrate. When it comes to our protein in the low-calorie diet, you'll have an equation that reads 3A plus B plus 3c equals 18. And this simply means that you'll find 3 grams of protein in dish A, 1 gram of protein in dish B, 3 grams of protein in dish C, and a total count of 18 grams for the low-calorie diet overall. These 3 equations make up your system with 3 variables, and now we'll be writing this system as an augmented matrix. So what we'll have now is an augmented matrix with coefficients 2, 1, 1, 10, as well as 1, 2, 2, 14, and 3, 1, 3, 18. And this is your augmented matrix for example 7. I really hope you guys appreciate the fact that we took the time out to present to you a word problem that can be solved using matrices in row echelon form. Okay, go ahead and make sure you give us a thumbs up and share the video along the way. Yeah, so what I want to do next is I want to first of all swap out row 2 and row 1. So I'm swapping out row 1 and row 2 because I see that it has the coefficient that I want. So the only row that is unchanged is the last row, 3, 1, 3, 18. And what we're going to do now is swap out row 1 with row 2. We'll have 1, 2, 2, 14, and your new second row is going to be 2, 1, 1, 10, just like that. For my next step, I'm going to want a 0 where the 2 in the second row is. So I'll be multiplying -2 times row 1 and adding it to row 2, putting the result in row 2. That means that my first and third row doesn't change one bit. All right, they won't change. So the third column, I have 3, 1, 3, and 18. And I'll be multiplying -2 times 1 to give me -2. -2 plus 2 is 0. Then I'll have -2 times 2 is -4. -4 plus 1 gives me -3. I have -2 times 2 gives me -4. -4 plus 1 gives me another -3. And then -2 times 14 is -28. -28 plus 10 is -18. And this is going to be our new second row after we complete that operation. All right, next I'll be wanting a 0 where the 3 is in the third row. I can get that by multiplying -3 times row 1 plus row 3, putting the result in row 3. What does this give me? This gives me an opportunity to bring down my first 2 rows unchanged. We'll have 1, 2, 2, 14, as well as 0, -3, -3, -18. And then we also have row 3 where we'll be multiplying -3 times row 1 and then adding that product to row 3. So we'll have -3 times 1 is -3. -3 plus 3 gives me 0. -3 times 2 is -6. -6 plus 1 gives me -5. -3 times 2 is -6. -6 plus 3 gives me -3. And then -3 times 14 is -42. And -42 plus 18 is -24. And now I want to get a 1 in the element in the second row, second column, aka where this -3 is in the middle. I can do that by dividing row 2 by -3, putting the result in row 2. That means that the first row and the third row will go unchanged. So we'll bring down the 1, 2, 2, 14. The third row is 0, -5, -3, and -24. And then for the second row, just divide each and every element by -3. 0 divided by -3 gives you 0. -3 divided by -3 is 1. Then -3 divided by -3 also gives you 1. And -18 divided by -3 is 6. So our next goal here is to get a 0 in the third row, second column. The way I propose we do that is to multiply row 2 by 5. So I'm going to say 5 times row 2, add that to row 3, put the result in row 3. And that's our next operation, guys. This means that the first 2 rows will go unchanged. Bring down the 1, 2, 2, 14. Then bring down your 0, 1, 1, 6. And then finally, to get the third row, we're going to multiply 5 times 0 to give you 0. And then 0 plus 0 is 0. Then 5 times 1 is 5. 5 and negative 5 combine to give you 0. We then have 5 times 1 is 5. 5 and negative 3 combine to give you positive 2. And then 5 times 6 is 30. And 30 and negative 24 give you 6. So this is our current result before we do our last step here, guys. And what is that last step? You got it. Putting a 1 right here where that 2 is in the third row. We can easily do that by dividing row 3 by 2, putting the result in row 3. That means that our first 2 rows will go unchanged. So just bring that information down, guys. 0, 1, 1, 6. And now divide every element in row 3 by 2. So 0 divided by 2 is 0. 0 divided by 2 is 0. 2 divided by 2 is 1. And 6 divided by 2 is 3. You now have your augmented matrix in row echelon form. You know this to be the case because the elements in your main diagonal are all 1s and you have 0s underneath those 1s. Okay, so that being the case, then we will now back substitute. So in back substituting, you'll have A plus 2B plus 2C equals 14. You'll have B plus C equals 6. And you'll also have C equals to 3. In this case, we already know the value of C, and we know that value is 3. So using this value, we'll be plugging that into the second equation. So I'll have B plus 3 equals 6, replacing the C with the 3 there. Then solving for B, we find that the value of B is 3. Using these 2 values, we'll be plugging that into our first equation. So we'll rewrite the equation as A plus 2 times 3 plus 2 times 3 equals 14. This then gives me A plus 6 equals 14. And simplifying, you'll have A plus 12 equals to 14. Subtracting 12 to both sides of the equation, you'll find that A equals to 2. This value of A is going to be the last value that you needed in order to write your result. And what is your ordered triple? You'll have 2, 3, 3. And what does this mean in the context of our word problem? You'll need 2 units of dish A. You'll also need 3 units of dish B. And you'll also need 3 units of dish C. And this is going to be the answer for problem number 7. Red box it. So here we have our simplified form. And if you're going to spell it out for your word problem, guys, this is the expanded version here. So this tells us how many of each dish we'll need to solve that problem. Done and done, people. All right, then, guys. That means that I need you to please like, comment, share the video with everyone you know and love, because this concludes this video on the Gaussian Elimination Method, aka solving matrices in row echelon form, presented to you by Mr. Whitt and Fort Bend Tutoring FBT. Don't forget to subscribe to our YouTube channel and to share with someone that you love, that you hate, and of course your classmates and your teachers. Let them know about the video, guys. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net. and set up a private tutorial with me and FBT. Oh yeah, baby.